Hey everyone, welcome back to the channel. My name's Jason. Thanks for checking out the video today. I'm super excited because we're checking out this huge power station. This is the Bluetti AC200P. Now, if you're in the market for a power station with 2000 watt hours, this is an excellent option because it has premium components inside and the build quality is really good. Now, this power station comes in at 60 pounds, and the reason that's that heavy is because it has lithium iron phosphate chemistry inside. So in exchange for a little bit more weight, you do get many more life cycles on the power station. This gets 3,500 life cycles, and you'll still have 80% of the capacity remaining. So that means you can take it from 100% down to 0%, 3,500 times, and still have around 1,600 watt hours of capacity. Now, this power station has the ability to charge or power 16 devices at the same time, including 2 wireless charging pads on top that are 15 watt chargers each, and then all the connections on the front that I'll show you here in a little bit. Now, not only can you charge or power up all those devices, but this supports a ton of input. You can charge this power station with 700 watts of solar input, and you can also charge it with the included AC adapter at 500 watts. And at the same time, you can charge it at 1200 watts to charge it up in 2 to 2.5 hours, which is pretty awesome. Now, this is priced at $17.99 on Bluetti's website with a $100 coupon off. I'll include that link down below. Now, in my videos, I do extensive testing these power stations to make sure they stand up to their advertising claims. I want to make sure that if you're going to go purchase this, you're going to get your money's worth. So let's jump into the front panel testing. Hope you guys are excited. Now, looking at the front panel, I want to talk about the DC outputs and the USB ports. Now, to turn any of these on, you do have to push the DC output button and then select on. You'll hear a relay click on, and then you're good to use any of these ports. Now, starting with the DC output options on this side, what's really cool is this has a 12 volt, 25 amp output that's an aviation style plug. This is the only power station that I know that has a 25 amp dedicated output. We will be testing to see how many watts we can pull from this. Stay tuned for that a little bit later. And then you have a 12 volt cigarette plug that supports 10 amps. And then you have 2 5521 barrel connectors that support 3 amps each. Now, it's important to note that all these outputs here are regulated at 13.4 volts, so you shouldn't have any issues running 12 volt appliances. Now, there are 5 different USB ports on this power station. Now, the first one is a power delivery 60 watt port. It's a USB type C port. Now, it would have been nice to see a 100 watt charging port here, but it's only 60. The next are actually USB-A ports. They each support 3 amps at 5 volts. Now, in addition to all the other output options, Bluetti also has 2 wireless charging pads on the top of the power station. Each one supports 15 watts. Now, as a note, you do have to have the DC output enabled here on the screen for these wireless charging pads to work. Okay, so I'm excited to do some testing on the DC output. I have 2 of my battery load testers connected together in parallel. We're going to start with the 25 amp connection, then we'll move over to the 12 volt cigarette plug and the barrel connections. Now, as an important note, if you want to use this 25 amp output connection, you do have to purchase this additional cable off of Bluetti's website. Okay, so both battery load testers are connected up, pulling 12.5 amps each out of the 25 amp connection. So we are successfully pulling 25 amps. So on the screen, you see we're pulling around 330 watts. Now, that's the most amount of wattage I've ever pulled from a power station, especially using dual battery load testers. So if you're looking for a power station that supports a lot of DC output wattage, this is going to be your option. And right here, I'm testing the 12 volt socket. I'm pulling around 135 watts or about 10 amps. Now, if you go up any higher, it does shut off from pulling too much power. Now, you do have the ability to pull 10 amps from the 12 volt socket and 3 amps from the barrel connectors down below. So you can get a total of around 175 watts before it shuts off from pulling too much power. Now, this beast has the ability to charge or power a ton of different devices at the same time, whether it's wireless charging, USB ports, or the 12 volt output. Everything seemed to work really well when I tested it all at once. Okay guys, let's go ahead and move forward with the DC capacity test. Now, the purpose of this test is to see how many watt hours we could pull from the battery as we take it from 100% down to 0%. Now, I hooked up both my battery load testers here in parallel to the 25 amp output. Now remember, this is rated at 2000 watt hours, but with some losses in regulation and everything kind of running in the background, we should not expect an exact 2000 watt hours. Let's go ahead and turn these on, maybe 10 amps each, and see what happens. Okay, so I have both of these battery load testers hooked up and set to around 10 amps. Let's go ahead and see what it looks like on the screen. So the test has been going for about 10 minutes. You can see we're pulling around 268 watts here on the screen, and the battery's sitting at 97%. Now, this is a pretty big load. Most power stations can only handle 120 to 150 watts. So it's pretty cool to be able to pull 265 watts out. Let's let the test run. Let's see how many watt hours we can get. Okay, so the battery just hit 0%, the DC output just shut off. Okay, so the first thing we're gonna notice here is this one ran for 6 hours and 56 minutes. This one ran for 7 hours and 28 minutes. Now in the middle of the test, I noticed that this one had shut off and I'm guessing it overheated. So I had to turn it back on and turn it down to 9 amps and it didn't have any issues the rest of the time. So this one didn't run quite as long, but we were able to still pull a ton of power from both of these. Let's check out this one first and then we'll check this one out and add them up together. Okay, so on the first one that ran less time, we were able to pull 773.46 watt hours, or about 61.72 amp hours. Like I said, this ran for 6 hours and 56 minutes. Now looking at the second battery load tester, we pulled 937.19 watt hours, or 75.10 amp hours. Now adding those up together, it's 1710.65 watt hours. Now if we take that 1710, divide it by the total, which would be 2000, gives us 85.5% of the rated capacity. So anytime you take this from 100% down to 0% using the DC output, you should expect somewhere around 1710 watt hours or 85.5% of the rated output. Okay, so in the next section of the video, we're gonna be talking about the AC inverter on this power station. So this has a 2000 watt pure sine wave inverter. That means it can handle 2000 watts continuously. You can do a 2500 watt load for about 2 minutes. And if you go over 2500 watts, it will actually shut off from overload protection. Now, whenever you want to use the AC inverter, you push this button here and then push on, and then it activates these outlets. So you have 6 different outlets to choose from to power your appliances, and they all have these safety and dust covers to keep kids from putting stuff in here to get hurt, and also keeps dust and other particles out. Now each of these outlets are a 20 amp NEMA receptacle. Now measuring the output of the AC inverter, I get 120 volts and I get 60 hertz. And when I set this to oscilloscope mode, you can see we're getting a pure sine wave output. So after those testing results, we know this puts out very similar power you'd get from your power company through your wall outlet. Now let's go ahead and put a 2000 watt load on this and see if it can hold it for 15 minutes. Okay, so I just started the test. I have 2 250 watt heat lamps plus a 1500 watt heater all running on the inverter. Now taking a closer look at the screen, you can see we're pulling right around 2000 watts. I have a stopwatch going. We'll just let this go until it hits 15 minutes. So here's my stopwatch. It's been going for 4 minutes, 30 seconds, and we're sitting right at 118 volts under this 2000 watt load. Okay, checking in at the 10-minute mark, everything's still running perfectly fine. Now, one thing you'll note is if you're pulling 2000 watts out of this battery, because it has 2000 watt hours of capacity, this thing's going to be dead in about an hour or less with efficiency losses. So if you're looking to keep warm, if the power's out, there are better, more efficient ways to do this than running 2000 watts of heat. So I'd recommend using an electric blanket or a small portable heater to keep yourself warm. Then you'll get a much longer runtime on this battery. Okay, so we're coming up on the 15-minute mark. Everything seemed to run perfectly fine. Let's go ahead and shut this off and then we'll try running a little bit higher load, see if we can run that for 2 minutes. Okay, so I've added a couple more heat lamps. Each one's 125 watts, and I've also added this 200 watt heater. Should put us right up near 2500 watts. Let's go ahead and start this up. It's gonna be loud, but I wanna see if this will run for at least 2 minutes. I'm pretty sure this is gonna be beeping at us because we'll be over 2000 watts. Let's see what happens. Okay, we're pulling 2400 watts. It's beeping at us. Well, that's nice. It stops beeping after a little bit. Okay, we're coming up right on the 2-minute mark. It should shut down here in a second. There it goes. So it will run for 2 minutes over 2000 watts, but it will shut off if you're getting that fault of going over 2000 watts. Now what's nice is you can actually see the faults, what's causing the problem. And you just go until you see a yellow dot. You can see right here, inverter overload. So we were pushing it a little bit too far and it shut off. And once you go view the fault, it clears it out, so you're good to start it up again. Okay, so what did you guys think of those tests? I was really happy with the results. We were able to pull 2000 watts for 15 minutes. And we also were able to pull over 2000 watts for 2 minutes, just as advertised in the owner's manual before it shut off. So everything looked really good on the testing for the AC inverter. Now I want to do a few more tests. I want to try running a few power tools off the AC inverter. And of course we have to do an AC capacity test to see how many watt hours we get as we use the AC inverter from 100% down to 0%. Okay, so the first power tool that I want to test running on the power station is my portable air compressor. This has a 10 amp motor. Now this would be really useful if you didn't have power wherever you're building something, like a framing nailer uses an air compressor. There's a ton of other tools that you could run off this. Let's go ahead and turn this on and see what happens. Okay, so everything worked fine. Didn't see any voltage drop. This pulls around 1,000 watts. Let's move on to the next tool. Now the next tool I want to test on the power station is this Ryobi 10-inch compound sliding miter saw. Now this is an absolute beast. It has a 15 amp motor, so it's going to be pulling a ton of surge current off the power station. Let's go ahead and test it out, see if we have any issues. Okay, so we didn't see any issues running this saw off the power station. We did have a little bit of voltage drop because of that inrush of current, but even if this is plugged into your house, you'll see your lights dim, which is completely normal. So it's pretty awesome to be able to run this large of a saw off the power station. Now in these last two tests, we did confirm that you could run large power tools off the Bluetti AC200P. So if someone was in a power outage situation, or if they were in an off-grid situation and wanted to run these large power tools, they shouldn't have any issues. Now I quickly want to test the amount of parasitic drain that the AC inverter has on the power station. So I have the AC inverter turned on, the battery's fully charged up. We're going to give it 4 hours and see how many percentage points we lose during that time period. Okay, so during the test we dropped 10%. Now the test ran from 10:40 to 3 o'clock. So you can see that it drops about 2.5% per hour if you leave the AC inverter on without anything running. So whenever you have the power station turned on and you're not using the AC inverter, just remember to shut it off to save a little extra power. Now I also tested the DC output parasitic drain when I ran a 12-volt compressor fridge for 24 hours. You'll see that a little bit later here in the video. And during that test, we lost less than 1% per hour in addition to running the 12-volt compressor fridge. So I don't think the parasitic drain on the DC output is much at all. Now there's one last test that I want to run on the AC inverter of this power station. I want to discharge it completely and see what the usable watt hours are. So if we take it from 100% down to 0% using the AC inverter, it'll tell us how many watt hours you'd expect to see while using it and also the efficiency of the AC inverter. Let's go ahead and plug everything in and start the test. Now this has been running for a couple minutes. We're showing 97%, pulling 395 watts. Now this unit here is tracking our kilowatt hours. Let's go ahead and let this run all the way down until the AC inverter shuts off and we can track the actual efficiency. Let's see what happens. Okay, so the inverter just shut off when the battery hit 0%. Now this ran for about 4 hours at 395 watts. Let's go ahead and take a closer look at the kilowatt meter. Now looking closer at the meter, we pulled 1.75 kilowatt hours or about 1,750 watt hours. Now that means taking the battery from 100% down to 0% using the AC inverter, you should expect somewhere around 1,750 watt hours. Now to find out the efficiency of the AC inverter, we can take that 1,750 divided by 2,000 and that gives us 88%, which is really good on a power station. So I'm really happy with these results. Let's go ahead and take a minute to talk about charging up the AC200P. Both charging inputs are on the left side of the power station. So looking at the right, you have your first charging connection. This one has a dust cover on it, and if you lift that up, it's an 8mm barrel jack. Now this is dedicated just for the included AC wall charger. It supports 58.8 volts and 500 watts max, so don't expect to plug anything else into this charging port. Now the second charging port is pretty interesting. You have a couple different settings that you can adjust on the screen of the power station. The first setting is for car charging. That accepts 12 to 30 volts at 8.2 amps. And then the second setting is PV or solar input that accepts 35 volts up to 150 volts at 12 amps max. This is an aviation style connector. It comes with a dedicated cable. Let's go ahead and show you how that works. Okay, so here's the charging cable that it comes with. Like I said, aviation plug on this side, XT90 on this side. So let's go ahead and plug this in. Now, once you connect up this cable here, you have two other charging options. The first option is for car charging or charging off another battery. You have a 12-volt cigarette plug and then this XT90 connection that plugs in here. The other charging option is for solar panels or PV input. You have MC4 connections that connect directly up to your solar panels, and then this XT90 plugs in here. Now here's a simple demonstration of how you can use the 12-volt cigarette plug to charge up the power station. You plug this end into a 12-volt cigarette plug, connect it up to the adapter cable, and then you're going to put around 105 to 106 watts into the power station. Now, just to remind you, we do have the power station set to the car charging setting, which is 12 to 30 volts input with an 8.2 amp limit. So we're not going to see any more than 100 watts charging using a 12 volt battery. But what if we step up the voltage? We can get more power. So I took this 12 to 24 volt converter. So it's taking the 12 volts of this battery, stepping it up to 24 volts. And now we're getting 200 watts charging off a DC power source using the car charging setting. Okay guys, we're about to jump into solar testing, but I want to do one other thing before jumping into the full-scale solar tests. Now, if you remember, the PV input is 35 volts up to 150 volts, so unfortunately a 12 volt solar panel does not fall within that threshold of voltage, so you can't use a 12 volt solar panel while charging this power station. You actually have to have two of these panels connected together in series. However, what I want to test is having it set to the car charge mode, where the voltage range is 12 to 30 volts, and plug in a 12 volt solar panel and see what happens. I'm hoping that we should be able to at least charge up the power station at maybe 150 watts or so. Let's go ahead and see what happens. Okay guys, check this out. 176 watts input. I have two 180 watt panels connected together in parallel, sitting at 21.5 volts, 8.2 amps, 176 watts. So pretty awesome. It looks like you can use 12 volt solar panels as long as you have it set to the car input charge setting. Okay guys, pretty interesting. I don't think I've ever seen anybody test that, so it's good to know that you can actually use 12 volt solar panels on this power station. Now, the only reason you would want to do this is if you have 12 volt solar panels you can't connect into series, at least you can get some power input on this power station. Obviously, you're going to get way more power if you plug into this port using the PV settings. In fact, let's go ahead and do some full-scale solar testing on the power station. So I have 4 of my 180 watt Bouge RV solar panels. I have 2 of them connected in series, and then these 2 connected in series, and then they're connected together in parallel for a 2S2P combination. Now this is a 12 gauge wire going inside my house, so we shouldn't see much voltage drop with the higher voltage. Now the solar conditions aren't perfect, but they'll be pretty good. It's around 35 degrees. We have a few clouds in the sky. Now some of you may be wondering why the panels are tilted up so high. Well, it's because it's in the middle of the winter. The sun is really low in the sky, so you have to tilt it up this much. Now by using the can trick on the solar panel, you can get the perfect angle. You can see that we have just a little bit of shadow on the side of the can. So in about 20 minutes or so, this should be facing the sun directly. Well, now that we got everything hooked up, let's go ahead and wait a few minutes for the sun to align with the solar panels. Then we'll see how many watts we're getting in on the power station. Okay, so we're back inside. Now that we're using higher voltage solar panels, we're going to go to the settings and change the DC input source to PV so it accepts a higher input voltage. Let's go ahead and hook up the solar panels. Okay, so we have the solar panels connected up. We're getting 447 watts input from the solar panels. You can click on this here and it'll tell you everything that's coming in. So we have 37.6 volts at 11.9 amps. So we are hitting the amperage limit. So I might have to try these in a series connection. The input power is 447 watts. Now it also shows you all the energy you've produced over time off solar power and the carbon dioxide emissions that you're saving as you're using solar panels. Okay guys, I just finished connecting the solar panels in series instead, and now we're getting much more power input, 585 watts. Now you can see we're getting a higher voltage and less amps, which means we're not hitting the amperage limit now. You could probably even connect a few more solar panels in series to get more power, but 588 watts, that's pretty awesome. Now this is definitely the most solar input I've ever gotten on a power station. Now the solar conditions aren't perfect today. Now I'm hoping maybe if I test this later in the summer with a better sun angle and also less clouds in the sky, we should be able to get near 700 watts. Now I thought it'd be helpful to test if this has pass-through charging while having a large solar input. So I hooked up my 1500 watt heater to the AC inverter. It's pulling around 1450 watts. We're getting around 590 watts input. So yes, this does support pass-through charging while having a solar input. Okay guys, now that I've showed you how to charge this on a car and also 2 different types of solar, there's still one other way to charge it, and that's using the included AC wall adapter. Now this charging brick is a 58.8 volt 8 amp charger, so you should see around 470 watts max. Now because it's such a high power charger, there is a fan that runs all the time whenever it's plugged into the wall. And here's what it'll look like when you're using the wall charger on this power station. You see we're getting 449 watts input. Now if you want to charge up this power station even faster, you can purchase an additional 500 watt charging brick off Bluetti's website along with an adapter. When you plug both these in, you can get around 900 watts total charging. Now in order for this to work, you do have to make sure the DC input source is set to PV instead of car charging, so it accepts the higher input voltage on that secondary charging port. Okay guys, I know that was a ton of information about charging up this power station, but it's pretty flexible and you have a ton of different options. Now I briefly want to show what comes in the box so there's no confusion on if you have to buy anything. The first thing you get is this 500 watt wall adapter that plugs into the 8mm connector. The next adapter that you get is this aviation style plug that has a XT90 connection. And then you get these two cables that connect to that one, a car charging cable and then a solar MC4 cable. Now all of this fits inside this bag that Bluetti provides, so it's nice you have a place to store it all. Now of course this definitely supports pass-through charging, so whether you're using the DC output, USB ports, or AC inverter, you can charge it and discharge it at the same time. Let's go ahead and take a minute to talk about the power station display. It is amazing, it has a ton of information. Right here in the middle, you have a large battery percentage with a ring around it that tell you how full it is. Then you have whether your DC outputs or your AC outputs are enabled. And then you have each information for each of the outputs or charging inputs. What's really cool is you can click on these. It'll tell you the information for the car or solar charging, the voltage, amperage, wattage, everything like that. Really cool. You can click on your DC load. See, it's regulated at 13.5 volts and gives you all the information about each of the outputs, even the wireless charger on the top. You can click on your wall adapter charger. It tells you the input voltage, the amps, and the watts. Now this is almost full, so the charger's tapering off. You can also do the same thing about the AC inverter. You can see the output voltage and the power and the hertz. So very cool information on each of these options. Now remember, when you have these on, it is using background power. So to turn them off, you just click these buttons and you can turn them off very easily. Just make sure that anytime that you're not using these outputs, you have them disabled, because you'll lose around 1% of battery if these are turned on and you're not using them. Now at the top of the screen, you have your time and date. I have not adjusted those. Those are default, so I'll need to adjust those a little bit later. Now on the left side of the screen, you have multiple setting options. The home page is this here. You can go into the settings. You can adjust the voltage of the AC inverter and the hertz, which is really cool. You can adjust the input source, whether it's high voltage or low voltage, solar or car charging, and eco mode. This will allow it to turn off automatically after a given period of time. I have this disabled so I can run 12 volt compressor fridges. You can also change the language. You can turn off the buzzer if you don't like that, and you can adjust the time and date by clicking here. Now if you look at the data, you can see all the product info. The inverter and charger info is basically what I've already showed you. The BMS maintenance will tell you the total voltage of the battery, the power coming in, and the battery state of charge. And you can see the battery is currently at a charge state. Now the fault history is basically whenever you overload it, it gives you a fault and you can view those there. Now one thing that I really like is at the top you have a system temp. It gives you that in Celsius and Fahrenheit. And because this has been charging for about an hour and a half, it's sitting at 102 degrees Fahrenheit inside the unit. And then you can come to faults here and you can see what all the faults are and their codes. And basically it'll tell you what's wrong for each fault. Now if there's anything that I would change for this, I'd like to have a way you can turn off the display to save some background power. And also if there was a Bluetooth app to be able to control this, that would be really cool. Overall, I'm very happy with this display. It shows me everything I'd want to know, and it's definitely the best display that I've used on a power station. Now one test that I think is super important to test on these power stations is to make sure that the DC output will stay enabled for a long period of time. And one way I like to test that is by plugging in a 12 volt compressor fridge and letting it run for over 24 hours. So I plugged in my IceCo Go 20, set it to 35 degrees, and let it run. Now this test has been running for about 26 hours, and looking at the screen, it's only used 16% of the capacity. That means it's less than 1% per hour, including standby time and running the fridge. So it looks like this doesn't have an auto shut off feature, which is really great, and you should expect a really long runtime using a 12 volt compressor fridge. So depending on ambient temperature, because my basement's around 70 degrees, should get at least 3 days to 5 days full runtime without any charging input. So one test that I thought would be super useful for the AC200P would be to run a full-size fridge like the power's out to see how long that fridge would last. So I'm down in my basement, we have a full-size fridge down here. I plugged it into the AC200P. Let's go ahead and see how long this battery lasts.
Many hours later.
Okay guys, it's the next morning. The fridge is still being powered by the AC200P. Let's go ahead and look at the screen to see how much percentage we have left. So we're sitting at 40% capacity. Let's go ahead and let this run the rest of the day and see how long it lasts. It's been going for 14 hours so far. Okay guys, the battery's down to 1%. Now you can see when the fridge is running, it's pulling around 156 watts. Now I started the test yesterday at 5:50 p.m. and it's about 5:21 right now. So it's been almost 24 hours. I'm gonna go ahead and stop the test here. Now you can see that we almost got 24 hours runtime off the AC200P. Now, a few things to consider with a test like this. A larger fridge is going to pull more power, and maybe a newer model will be more efficient. This is a pretty old fridge. Also, if it's warmer, the fridge is going to have to run more, so you'll get less run time. Okay guys, we finished all the testing. What do you guys think of all those results? Now, it was a ton of information, but just remember, I do these tests so you guys can know if this power station will fit your use case scenario and if it's right for you. So hopefully after all that testing, you know if this one is a good power station for you personally. Now, there's two last things that I want to talk about. One of them is just this pamphlet here. It has the owner's manual in it. Now, the owner's manual is very detailed. It has a lot of pictures, easy to read. Definitely recommend you read through the owner's manual about this power station if you pick it up. The next thing in here is just a contact or warranty card. It talks about how you can contact them if there's an issue, and it talks about the 2-year warranty on this power station and a 1-year warranty on all the accessories. Okay, so the last part of the video is how does this power station stack up to the 7 required features that every power station should have? I like to also call this the Jasenoid gold standard for power stations. So the 7 features, let's fly right through them. Number 1, does it charge from 0% to 100% in less than 4 hours? Yes, this one can charge in 2 to 2.5 hours, which is pretty awesome. Number 2, does this support pass-through charging? Yes, you can use the power station and charge it at the same time, no issues there. Number 3, does this have a pure sine wave inverter? Yes, we tested it, 120 volts, 60 hertz, pure sine wave. Number 4, does the power station have a regulated output? Yes, this has a regulated output of 13.4 volts. Number 5, does this have a display that shows you all the information you need to know? Yes, out of all the Bluetti power stations that I've tested, this one has the best display. The only thing that I would change is it needs to have an estimated runtime. So if you're going to do a version 2 Bluetti, add an estimated runtime to the current load on the display. Number 6, does this power station have any auto shutoff features on the DC output or the AC inverter? Yes, there is an eco mode, but it is disabled by default. You can actually find it in the settings, so you shouldn't have any issues running a 12-volt compressor fridge or any other fridge or appliance off the AC inverter or DC output. Number 7, does this power station have a USB-C 100-watt power delivery output? Unfortunately, this power station has a 60-watt output, so if you absolutely need the 100 watts, you're gonna have to pass on this power station because this one doesn't have it. Okay, well there you guys have it. This is the Bluetti AC200P. Really impressed with the testing results. Let me know what you guys think about this power station, or if you have one, how has your experience been? Also, let me know if you guys think I should do any other tests on my power station reviews. Throw the comment down below. I'd love to get your guys' feedback. Also, I have a really exciting video coming out in the future. I will be doing a grading system for all the power stations on my channel. I have, I think, 13 of them now, and it's really hard to know which one's the best. So I came up with a 10-point grading system that you guys are really gonna like. And I'll just give you a little hint. This one did really well on that grading system. Now, if you guys like this type of content, power station reviews, solar panels, 12-volt compressor fridges, DIY projects, feel free to check out the other videos on my channel. And if you like that content, maybe you'll like the stuff in the future. So I invite you guys to subscribe to the channel if you're not already subscribed. Anyway, guys, thank you so much. We'll see you guys in the next video.